Question 1. So we're given here a table of probabilities, and we know that the probabilities have to add up to a whole, have to add up to 1. So basically, to work out this missing probability here in the table, add up all the other numbers, take this away from 1, and you get 0.31. So that's the probability of throwing a number 1. Now we're being asked to work out something to do with when you throw either the number 1 or the number 3. So the probability when you throw one dice of throwing a number 1 or a number 3 is these two probabilities added together. So that's 0.31 add 0.18, which is 0.49. So basically, if you roll the dice once, the probability of it landing on a 1 or a 3 is 0.49. So if you roll it 200 times, the number of times you'd expect to land on 1 or a 3 is 200 lots of this 0.49. So 200 times 0.49 is 98. Question 2. Now I thought this was incredibly difficult for the second question on a paper, particularly when you're all nervous and just trying to settle down. So my suggestion to you, if you get one of these questions, particularly early on when you're bombarded with information, is just write down what you know in a two-way table. So all I've done here, I've just set up my two-way table, so I've got adults and children across the top, and then the circles or the stalls down the side. And in this table I'm going to put down all the information I know about the seats that are occupied. So from the question, I know 117 children had seats in the circle, so that's the first thing I've addressed, and I've put the 117 down here. Now, not that it's going to go into the table, but the other thing I've noted down here is that there are 2,600 seats in the theatre. So I've just popped that down here at the bottom. Now, thirdly, I'm looking at this point here. We're told that 3/4 of the children had seats in the stalls. Now, 1/4 had seats in the circle. So 3/4 is going to be 3 lots of this. So the number of children who had seats in the stalls is 3 lots of 117, which is 351. So that's the third thing I've done. So I can now add up these two numbers for the children sitting in the circle and children sitting in the stalls to get 468 children in total. Now the next thing I've done is to go back to this opening statement that we're told that the ratio of the number of adults to the number of children was 5:2. So 2 parts represents the number of children. So 468 represents the 2 parts. So 1 part is going to be 468 divided by 2, which is 234. And then, given that that's 1 part, 5 parts, which is the number of adults, is going to be 5 lots of this. So 5 lots of 234 gives us 1170. So that's the total number of adults. So we've got 1170 adults and 468 children. So altogether, the number of seats occupied is when we add these two together, which is 1638. Now we're being asked, are the number of people on this Saturday taking up more than 60% of the seats? So the total number of seats taken up is 1638 out of the 2,600. So let's work that out as a percentage. So 1638 divided by 2,600 times by 100 gives us 63%. So yes, more than 60% of the seats were occupied on the Saturday because 63% were occupied. Question 3. So on the centimetre grid below, draw the front elevation and the side elevation using a scale of 2 centimetres, so that's 2 squares for every 1 metre. So the front elevation is just the view you would have if you're standing here looking forward. So you're going to have a base of 2, a height on the left of 2, height on the right of 0.5, and then the diagonal. So the front elevation is going to be looking just like this front view here, But remember, we're saying it's 2 centimetres, so 2 squares for every metre. So we're basically doubling all of these measurements. So 4 squares, and 1 square. Now for the side elevation, you're standing over here. So what you can see in the foreground is going to be this little rectangle here, which is 1 metre by half a metre. So obviously using this scale here, that's going to be 2 squares by 1 square. And that's this little bit here. But do remember, you're also going to see the behind, you're going to see the slanty roof up to the height of 2 metres. So this bit here represents the slanty roof. So that's the height at the front, and really that's the height at the very back. So just think of that bit down there as being the flat wall here, then this bit here being the slanty roof up here. Question 4. So Ollie's driven 56 kilometres from Liverpool to Manchester, and then 61 kilometres from Manchester to Sheffield. The average speed for the first part of the journey is 70 kilometres per hour, and then we take 75 minutes for the second bit. And we've got to work out the average speed for his total drive. So to work out the average speed, we're going to need to know the total distance travelled, which we do. That's 56 kilometres and 61 kilometres. So the total distance travelled is 117 kilometres. And we're going to need to know the total time taken. Well, we know the time taken in minutes for the second part of the journey from Manchester to Sheffield, but we don't yet know the time taken for the first part of the journey from London to Manchester. So let's hone in on what we're told. We're told that he's travelling at 70 kilometres per hour. That means in an hour he would travel 70 kilometres. He would travel 70 kilometres in an hour, or in other words, he would travel 70 kilometres in 60 minutes. So how long would it take him to travel these 56 minutes? Well, scale back. Take your 60 minutes, divide by 70 kilometres to get back to the time for 1 kilometre, then multiply by 56, and that gives you the 48 minutes. So it takes him 48 minutes to travel the 56 kilometres. So this is just direct proportion, okay? So the 70 to 60 is the same proportion as 56 to 48. So the first part of the journey takes 48 minutes, the second bit took 75 minutes, so that's 123 minutes in total. So to work out the speed in kilometres per minute, I've done 117 divided by 123, which simplifies down to 39 over 41. But I don't want to know how many kilometres he goes in a minute, I want to know how many kilometres he goes in an hour. Now there are 60 minutes in an hour, so you can go 60 times as far as this. So you multiply 39 over 41 by 60, giving you 57.07 ... Now it doesn't specify how many decimal places or what have you that it wants the answer, so I've just chosen to go to 1 decimal place, which is 57.1. The mark scheme allows anything between 57 to 57.1. Now for part B, we're told Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometres and 60 kilometres. Well, that's only going to apply if the time taken for both parts of the journey must be the same. That's the obvious answer. Okay, so in order for this to be the case, it's not the distance travelled being the same, because it's travelling it at a different rate. What needs to be the same as the time taken for both parts of the journey. Now, just for completeness, there is an alternative correct answer, which I've just extracted from the mark scheme over here. Alternatively, you could say the distance from Leeds to York is 3/4 of the distance from Barnsley to Leeds. So that's absolutely fine as well. But if I were you, I would just focus on the first bit, that the time taken for the two parts of the journey must be the same. Question 5. So here we've got similar triangles. So I think in order to gather our thoughts, it's a good idea just to do a little sketch of the bigger triangle EAC next to the smaller similar triangle DBC, and then just fill in the measurements that you're given. So we know this from E to C is 8.1, D to C is 5.4, and D to B is 2.6. So we then look for the common side, which is obviously the base, and we can see what's the scale factor to go from the smaller one to the bigger one. Well, if I've done 8.1 divided by 5.4, I get 1.5. So basically, this shape is 1.5 times bigger than this one, or this one is 1.5 times smaller. Now for part A, we're being asked to work out the length of AE, this bigger side here. Well, we've just said it's going to be 1.5 times bigger than 2.6, so 2.6 times 1.5 is 3.9. Now for part B, we've got to work out the length of AB, and we're given that AC is 6.15. So we're given that AC is 6.15. So knowing this, we can work out the length of BC. And on this occasion, as we're trying to establish the smaller length, we've got to divide by 1.5. So the length of BC is 4.1 centimetres. So from B to C is 4.1. A to C is 6.15, so A to B must be the difference. So that's 6.15, take away the 4.1, which is 2.05 centimetres. Question 6. So I've done the quick way of doing these. There are longer ways of doing it. So anyway, starting off with personal bank. So we're investing an amount of 25,000. The interest rate is 2%, so that gives us a multiplier of 1.02. Had it been 4%, say, it would have been 1.04. So the multiplier is 1.02, and we're investing it for 3 years at this same interest rate, so that's the power we apply to the multiplier. So 25,000 times 1.02 to the power of 3 gives us a total amount that Anil will have after the 3 years of £26,530.20. So the actual interest that he's accrued is going to be this less the initial sum he invested of 25,000, giving him the interest of 1530.20. Now alternatively, he can invest the same 25,000 at the secure bank. Now we've got 1 year's worth at 4.3%, so that gives us a multiplier of 1.043. Now that's just for 1 year, so that's effectively to the power of 1, but obviously that's just the same as 1.043, so I haven't put the power in there. And then it's at 0.9%. Now be careful, that's a multiplier of 1.009. 1.09 would have been if the interest rate had been 9%. So just be careful, you've got the 2 zeros there. Now that's for each extra year, so that's for the 2 extra years of the 3 years. So that's why that's to the power of 2. So that's squared. Pop that into your calculator, you get this number here, 26,546.46. That's the total amount after the 3 years. So take away the initial amount invested, giving him an interest of 1546.46, which is slightly better. So you can then conclude that Secure Bank gives the most interest at the end of 3 years. Question 7. So using inequalities, so that's when we use these greater than or equal or less than or equal to signs. So that's what the inequalities are. And then the error interval is just giving us the upper and lower bounds. So 4.76, the lower bound for that, what's the smallest number out there that when you round it to 2 decimal places you get 4.76. Well, that's 4.755 inclusive of 4.755, because 4.755 rounds up to 4.76, but anything smaller than this doesn't. So that's the very smallest number that will round to 4.76. Now at the upper bound we need all the numbers that are less than 4.765, because 4.765 itself would round up to 4.77, but 4.76499999, so just a fraction below this, rounds down to 4.76. So just be careful that you remember that with the lower bound you include the lower bound itself. You got greater than or equal to 4.755, but for the upper bound you make it less than that. Okay, so you've got the symmetry in the two numbers. They're both 0.005 away from this, but you've got to include the equal sign on this inequality, but not include it on this inequality. Question 8. So we're being asked to work out an estimate of the number of the students with a height greater than 160 centimetres. So that's fairly straightforward. So take your 160 centimetres, take a reading, and you get 48. Now that's going to be 48 people with a height less than 160 centimetres. You want these people up here, who are the ones who are taller than 160 centimetres. So that's going to be 60, there's 60 here, 60 take away 48, which is 12 people. So the common error is people say 48. Well, no, that's if you want people with a height less than 160. Question 9. So we start off with reflecting triangle A in the x-axis to get triangle B. So here's the x-axis, so reflecting A, we get B down here. We're then going to reflect triangle B in the line y equals x to get triangle C. So remember, the line y equals x is where all the x coordinates equal the y coordinates. So various points on the line are 1, 1, 2, 2, 3, 3, 4, 4, and so on. So it's that diagonal line there. So to reflect B across that, if you just go diagonally, so you've got that's like 1, 2, 2.5 squares away. So 1, 2, 2.5 squares away, and so on. So basically B reflected in the line y equals x takes us to C over there. Amy reflects triangle A in the line y equals x to get D, so that's just doing that one there. She is then going to reflect triangle D in the x-axis to get triangle E, so that's what I've done down here. Amy says that triangle E should now be in the same position as triangle C. Is she correct? Well, clearly she isn't correct because E's down here. Basically, she would have been correct if this had said she is then going to reflect triangle D in the y-axis to that triangle should be to get triangle E. So Amy then says triangle E should be in the same position as triangle C. So yes, so basically, had we taken D and reflected that in the y-axis, that would have taken us to E being in the same position as C, but it's not the y-axis, it's the x-axis, so Amy is not correct. But you do need to show all the positions of all the various triangles. Question 10. Write down the name of the planet with the greatest mass. Well, so you're looking for the greatest power here, and that is something with 10 to the power of 27, so the greatest mass is Jupiter. Find the difference between the mass of Venus and the mass of Mercury. So there's the mass of Mercury, there's the mass of Venus. Just literally pop those both into your calculator and you get this answer here, which is the correct answer, 4.5388 times 10 to the 24 kilograms. Now, Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is Nishat right? So let's go and take the distance from Earth of Neptune, which is 4.35 times 10 to the 9. Divide that by the distance that Venus is from Earth, 4.14 times 10 to the 7. So just pop that into your calculator. Again, I suggest you use the fractions button 3 down on the left hand side on a calculator, and that gives us an answer of 105.07 ... So yes, Neptune is over 100 times further away. In fact, it's about 105 times away. question 11. Now, there's several ways of doing this. The way I like to do it is really just to focus on trying to get each of the terms onto a single line, so we get rid of having fractions. So what's the lowest common multiple of 4, 3 and 6? It's 12. So if we go and choose to multiply each of these terms by 12, it still holds true. This term take away this term equals this term is still true if we multiply each of those three terms by 12, which is what I've done there in blue. Now once you pop that in, well, 12 divided by 4 is 3, 12 divided by 3 is 4, and 12 divided by 6 is 2. So I'm left with this revised problem here where the whole equation is just on one single line. And it's then just a question of number crunching. So multiply out the brackets, so we get 9x minus 6 minus 8x minus 20 equals 2 minus 2x. Gathering up the left hand side, that gives us x minus 26. Then adding 2x and adding 26 to both sides, we get 3x equaling 28. Divide through by 3, we get 9 1/3. Question 12. So we're told there are 30 students in Mr. Lear's class, 16 of the students are boys, 2 of the students in the class are chosen at random. So we're choosing 2 of the boys. So we choose one boy, here's the choice of the first student, and then we choose a second student. So the chances of choosing a boy with the first pick, that's right, that's 16 out of 30. But once that boy's gone, and you then pick a second student, the chances of picking a boy is now 15, of course, because one of the boys have gone, but it's no longer out of 30, is it? It should be out of 29, because one of the students has already been picked. So as you go to do your second pick, there's only 29 left. So basically, what's wrong with this tree diagram is these denominators should all be 29, not 30. Now for part B, Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Well, no, that's not right. If Owen's chances of scoring a goal is 0.4 and Wazim's is 0.25, the chance of Owen scoring and Wazim scoring comes about when you multiply these probabilities together. Okay, so when it's an or, you add them, but when it's an and, they should be multiplied. So no, so Mr. Slater is not right. These probabilities should be multiplied together. Question 13. So the key thing with histograms is to remember that the frequency, which is the number, so in this case the number of members, the number is represented by the area of each of these bars. So for example, if we take this first bar here, we've got a base of 10 and a height of 1.1. 10 times 1.1 is 11. So that represents the number of members who are aged between 0 and 10 in the club. So there are 11 members aged between 0 and 10. And so on. So each of these numbers here in blue, I've just worked out by working out the area of the rectangle. So simply the base times the height. So let's take this one here, for example. Base of 20. Height of 2.3, that's an area of 46. So when I've gone and added up those 5 areas, I've got a total of 134, so we can see that ties in with the number of members. Now we're told that 20% of the members of the sports club who are over 50 years of age are female, and we've got to work out how many that is. So first of all, we've got to work out how many members, be they male or female, are aged over 50. So if we take our 50 years here, so halfway between the 40 and 60, 50, draw a line up there, then the area to the right of this, so this little area here and this area here, the total of members, male or female, who are aged over 50. So this little area here, this right hand side of this bar here, is half of the 28, which is 14. Clearly this area is 21, so 14 add 21 is 35. So we have 35 members who are aged 50, be they male or female. Now we're told that 20% of these are female, so 20% of 35 is 7. Question 14. So really it's hard to explain these, you've really just got to learn them. So let's take the first one, the sine curve. Well, hopefully you know that the sine curve is one of these wavy curves, so it's either going to be D or C. And then really you've got your calculator, so you can always check to start off with. This one obviously goes through the origin. So is the sine of 0 0? Yes it is, so therefore that is the sine curve, not this one. This is actually the cosine curve, because cosine of 0 is 1. Now with the second one, it's the cubic bit, it's this first term that dominates. So just think of the curve y equals x cubed. Now y equals x cubed is going to be, well in fact you've only got the one to choose from. This is what a y equals x cubed curve looks like. Had it be going like this, sort of down there, that would have been y equals minus x cubed. And I think the easiest way to just check is think of a big positive x number, say 10. What is 10 cubed? Well, that's 1,000, so the point 10, 1,000 will be on that curve. So therefore that's in this first quadrant, that's up here. Right, now this is an exponential curve here, so they always look like this. And again, just think of some values. Let's say 2 to the power of 3 would be 8. So that would mean we've got the coordinate 3, 8 would be on the line. So that's going to be something along the corridor, something up the stairs. Similarly, anything to the power of 0 is 1. So 2 to the power of 0 would be 1. So when x is 0, y would be 1. Well, that fits, 0, 1. And when x goes into the negative, so say for example 2 to the minus 2, you get a quarter. You can check that on your calculator if you want. So we'd have minus 2 a quarter. And again, that fits, minus 2 a quarter. Now the exponential, these reciprocal graphs where it's sort of a multiple of 1 over x, again, you've really just got to, through experience, just sort of learn these, though you can check them. So we're really going to be weighing up between this graph B and this graph H. And again, if you're not sure, just take a value and think about it. When x is, say, 10, we're going to have 4 over 10, which is 0.4. So when x is 10, y is 0.4. So when x is 10, y is going up the stairs, so that must be H rather than B. For what it's worth, what are these other curves? So that was the other reciprocal graph, that was the cosine curve. That's the smiley face one, so that would be y equals an x squared graph. That would be a sad face one, that would be y to the minus x squared. And that would be a minus exponential graph. So that would be, for example, had we had y equals minus 2 to the power of x. Question 15. Now, the key thing here is to read the question carefully. We're trying to work out that these triangles are similar. So not congruent, because congruent would you be when you have to do that side angle side and angle side angle, or side side side. So similar just means they've got the same angles. Okay, so one can be bigger than the other, they're just sort of similar shapes. So basically, if you've got to prove that triangles are similar, you're immediately thinking angle, angle, angle. So I've got them shaded in the two triangles we're talking about here, and then basically the three angles are the same for the following reasons. These two blue angles are the same because vertically opposite angles are equal. Now this angle here and this angle here, these in green, are similar, and that's one of the circle theories because angles at the circumference are equal in the same segment. So basically if you bounce off from the line BC and go boom boom, if you bounce off from AD, you've got that angle ABD and that angle ACD are the same. So that's the green angles, whereas these two pink angles are the same for the same reason. It's another one where it's the angles at the circumference are equal in the same segment, but that is when you bounce off from CD. So if you CB, so if you go C to D to B, that angle there is the same as from C to A to B. So basically you've got circle theory for two of the angles, the pink one and the green one, of angles at the circumference are equal provided they're in the same segment, and the blue one's the same because the vertically opposite angles are similar. So it's angle, angle, angle. Question 16. So key bit here is using algebra. Clearly you can't just pop these into your calculator and then just say therefore they're equal to 1 over 33. So we're going to have to use algebra to convert this first recurring decimal into a fraction, and then secondly use algebra to convert the second recurring decimal into a fraction, multiply the two fractions together and get 1 over 33. So starting off with the 0.1363636, that's what I've done over here on the left. So let x equal 0.1363636 dot dot dot. Now because we've got the two dots, we choose to multiply by 100. So two dots, two zeros. So multiplying both sides by 100, we get 100x equaling, and then obviously the decimal, the numbers move over two places. So we're going to get 13.6363636. Now you'll see then that this recurring element here is lined up. So if we do equation 2, take away equation 1, we get 19x equals 13.5. Now I don't really want to divide through by 99 at the moment because I'm going to get a decimal over a fraction. So at this point I'm going to choose to multiply by 10. So 990x equals 135. Now I can make x the subject dividing by 990. So x is 135 over 990, and then dividing top and bottom by 45, we get 3 over 22. I'm just going to park that for now, and starting again. So let's now let y equal 0.2 recurring. So 0.22222 dot dot dot. Now we've just got the one dot here, so we just only need to multiply by 10 to line up the recurring components. So 10y equals 2.22222. Same idea, second equation, take away the first equation, we get 9y equaling 2. Dividing by 9, we get y equaling 2 over 9. So this first recurring decimal is 3 over 22 to be multiplied by the second recurring decimal, which is 2 over 9. How do we multiply fractions? It's top times top, bottom times bottom, giving us 6 over 198. Divide top and bottom by 6, we get 1 over 33 as required. Question 17. So let's start off by labelling our diagram with the information we're given. So we're told that AOB is an equilateral triangle of side 7. So obviously the length OB, BA and AO are all 7, and because it's an equilateral triangle, this angle AOB is 60 degrees. Now we're also told that ONQ is a sector of a circle with radius 11, so this total length O to N and O to Q must be 11. Now given that component is 7, that component must be 4. Now we've got to work out the area of the shaded area. Now to do that, I'm going to work out the area of this whole of this sector ONQ, and then take away from that the area of the triangle AOB. So let's start off by working out the area of the triangle. Okay, so the area of a triangle is half AB sin C, where C is the angle, so that's 60 degrees. A and B are the two sides that trap that angle, which is 7 and 7. So the area of the triangle is half times 7 times 7 times sin 60, which is 21.2176 dot dot dot. Now the sector ONQ is obviously a fraction of a whole circle. How do you work out the area of a whole circle? It's pi r squared, so that's pi times 11 times 11 again, but the fraction of the circle I want is 60 degrees worth, which is 60 out of 360. Obviously there are 360 degrees in a circle, so basically it's a sixth of a whole circle, which is 63.3555 recurring. So the area of the shaded component is the sector, take away the triangle, which is 42.1378 dot dot dot. Now we're being asked to calculate the area of the shaded region as a percentage of the area of the whole sector. So the area of the shaded region is 42.1378 dot dot. Divide that by the area of the whole sector, 63.3555 dot dot dot, times that by 100 to turn it into a percentage, and we get 66.51 dot dot dot. So to one decimal place, that is 66.5%. Yes, just thinking about it, up here when I said recurring, that may not be recurring, it's just dot dot dot. There's other decimals that follow. Question 18. Now, the key thing with a question like this is to really try and change the big number into a consistent number, which is really always going to be the smaller number. So really we want to rewrite the 16 and rewrite the 8 as multiples of 2, which obviously conveniently they are. So our first line of working is to rewrite the 16 as being 2 to the power of 4, because 2 times 2 times 2 times 2 is 16. So it's 2 to the power of 4 all to the 5th times 2 to the x equals, now 8 is 2 cubed, 2 times 2 times 2, so the right hand side can be replaced by 2 cubed all to the power of 3/4. Now from then onwards it's fairly straightforward. So we multiply the 4 and times a fifth to give us 4/5. We multiply 3 by 3/4 to give us 9/4. And then following the index rule, we know when we're multiplying we add the powers. So 4/5 add x, not times, but add x equals 9/4. So then it's really just playing with our fractions. So x equals 9/4, take away 4/5. Having a highest common, lowest common multiple, so basically a common denominator, multiply top and bottom of the first fraction by 5, multiply top and bottom of the second fraction by 4, we get 45/20 minus 16/20, 29/20, which is 1/9/20, or 1.45. Now obviously, because this is a calculator paper, at that point you could have just literally slotted this into your calculator, taking advantage of that fractions button, which is the third one down on the left hand side of your calculator. Question 19. Now, in order to subtract fractions, we're going to need to have a common denominator throughout. So our common denominator is going to be x plus 3, x minus 3. So with this first term here, which is 2, in order to have a denominator of x plus 3, x minus 3, I have to times top and bottom by x plus 3, x minus 3. With regard to this term here, x plus 2 over x plus 3, I only need to multiply top and bottom by x plus 3 to have the common denominator x minus 3, x plus 3. And with this third term here, I have to multiply top and bottom by x minus 3. So the key bits are the bits I've underlined in red. That allows us to have this common denominator, which is x plus 3 times x minus 3, which in other words is x squared minus 9, being x plus 3 times x minus 3. Now we can then bring all of these top numerators into a single term. So we're going to have to multiply out this, take away from that what this is multiplied out, and then take away from that what this is when multiplied out. So let's do the multiplying out first of all. Well, x plus 3 times x minus 3 is x squared minus 9. X plus 2 times x plus 3 is x squared plus 5x plus 6. And x minus 6 times x minus 3 is x squared minus 9x plus 18. Now this first bit is straightforward, just the claw, 2x squared minus 18. Now you've got to be ever so careful here. We've effectively got another claw here. This is like minus 1 times x squared minus 1 times 5x and minus 1 times 6. So make sure you get minus x squared minus 5x, not plus 5x, minus 5x and minus 6. And similarly over here, it's effectively a minus 1 in front, so we get minus x squared. Minus 1 times minus 9x is plus 9x, and minus 1 times 18 is minus 18. So the x squareds then cancel out, because we've got 2x squared minus x squared minus x. Gathering up the x's, we've got 9x take away 5x, which is 4x. And then gathering up the normal numbers, we've got minus 18, minus 6, minus 18, which is minus 42. So comparing this to the question, a is the coefficient of x, which is 4, and b is the number on its own, so that's minus 42. Question 20. So this graph, this curve is y equals x squared minus 2x plus 3. Now we're being asked to draw a suitable straight line to allow our graph to find estimates for the solution to x squared minus 3x minus 1 equals 0. Now we need to adjust the left hand side to line up with the graph that we've been given. So we're fine with the x squared. Now we need to have minus 2x when in fact we've got minus 3x, so we're going to have to choose to add x to both sides. Now we've got a minus 1 here, but we need to have plus 3, so we're also going to have to choose to add 4 to both sides. So when we do that, we end up on the left hand side with x squared minus 2x plus 3 equaling x plus 4. So what we're now saying is if we draw the curve y equals x squared minus 2x plus 3, which we've already got, we're looking for where that is equal to the line x plus 4. So we need to add the line x plus 4 to our graph. So that's simple enough. Just think of a couple of points on that line. So for example, when x is 0, y is 4. So 0, 4. When x is 2, say, y is going to be 6. And when x is 4, for example, y will be 8. So I've now got the graph here. This curve here is y equals x squared minus 2x plus 3. That's what we were told in the question. And we've also then added the line y equals x plus 4. So where is the curve equal to the line? Well, it's where they intercept. So if we just drop down vertical lines from this intercept here and this intercept here, I get values of minus 0.2 and 3.2. Now it's quite hard to do it on the graph, so there is margin for error in the mark scheme. So with this first value, anything was allowed between minus 0.4 and minus 0.2, and for the second value, anything was allowed between 3.2 to 3.4. Now we're told P is the point on the graph, so our curvy graph here, where x equals 2. So we know where x equals 2. So this point here is P. I've forgotten to label it, but that point there is P. And we're being asked to calculate an estimate for the gradient of the graph at the point P. So you've got to get your ruler out and just draw in your best shot at doing a tangent to the line at that point there where x equals 2. This is the line that I've put in. And with mine, I've now got to work out the gradient of my line. Well, the gradient is y step over x step. My y step is 7. My x step runs from 0.5 to 4, so that's the base of my triangle of 3.5. So I've got a gradient of 2. Now it's very, very difficult to accurately draw in this tangent, so the mark scheme is wildly generous with what it allows. So providing whatever tangent you've put in, you've worked out the height and the base correctly and divided correctly, you will get full marks. So anything between 1.6 to 2.5 was allowed. Here is to read the question carefully. It's a rectangle, it's not a square. At a cursory glance that looks like it would be a square, but as you can see that circle at the bottom doesn't carry on from the bottom of that circle, so it's a rectangle. So the first mark was easy enough to get because we're told that the radius of each circle is 24 millimeters. So obviously that length from there to there is 24, there to there is 24, and then with this circle that's 24 and that's 24. So the width of the rectangle is 4 lots of 24, which is 96. Now what we now need to do is to work out the height of the rectangle. Now we know this length here is 24, this bit here in pink. We know this bit here is 24 because that length there is obviously just the radius of that circle. So the key bit is to work out this stretch in purple. Now if we go and look at this triangle here, we've got a radius of a circle, radius of a circle, radius, 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 radius. So basically if we look at this little right angled triangle here, we've got this shorter length of 24, the hypotenuse is 2 lots of 24, which is 48, and we don't know the length xy. So it's a taking away Pythagoras, where xy squared equals 48 squared minus 24 squared, which is 24 root 3. So the actual height of this rectangle is 24 plus 24 root 3 plus 24. So, which is 48 plus 24 root 3. Obviously you can work this out and just use a decimal, that's absolutely fine. So the area of the rectangle is 96 multiplied by 48 plus 24 root 3, which is 8598.645 dot dot dot. So to 3 significant figures, that's 8,600. And that's not to 2, that's to 3, because obviously to 3 we're trying to round that number, which rounds to a naught. So it is 8,600 to 3 sig figs. Question 22. So you start off just by working out what the first differences are, which are 7, 11, 15 and 19. So the jump from 4 to 11 is 7, 11 to 22 is 11, and so on. Now if you then take the second difference, which is the difference between 7 and 11, 11 and 15, 15 and 19, you can see that they're consistently 4. So that's telling you that this is a quadratic sequence, so we've got an n squared, and because they're going up in 4s, a starting point is to say it's 2n squared. Had it been going up in 6s, we would have said 3n squared. Had this second difference been going up in 2s, we'd have just said 1n squared, so n squared. So our starting point is to consider the sequence 2n squared. Now remember, n is the position in the sequence. So this is when n is 1, n is 2, n is 3, n is 4, n is 5. So 2n squared gives us, here when n is 1, 1 squared times 2 is 2. This 8 is because 2 squared times 2 is 8. 3 squared times 2, 4 squared times 2, and 5 squared times 2. Now at that point we can see that we're still some way off our 4, 11, 22, 37 and 56. But what I can see is if that I choose to add n on to each of these, obviously n being 1, 2, 3, 4, 5, that I am then consistently only 1 away from the sequence that I've got. So basically if I add on n and then I add on another 1, I then add up with my sequence. So really it's just 2n squared is your starting point, and then you just see what you need to make up the difference. So my sequence is 2n squared plus n plus 1. Okay, so finally question 23. So I think it's best for me to draw a sketch to help explain this one. So L is the circle with the equation x squared plus y squared equals 4. So that circle has got centre 0, 0 and a radius of 2. So that's my circle in blue. And then I'm told that P is a point on L. So let's say that P is over here. So that's 1.5 along the corridor, root 7 over 2 up the stairs. And then I'm told find an equation of the tangent to L at the point P. So there's my tangent to L, the curve at the point P. So I need to find an equation of this line. Now what do I need to find an equation of a line? Well, I'm going to end up using the formula y minus y1 equals mx minus 1. So what I need is two things. I need a point on the line. Well, I've got that. I know the point P. So my x1 is going to be 3 over 2, my y1 is going to be root 7 over 2. Secondly, what do I need? I need to have the gradient of the tangent. Now the tangent is going to be perpendicular to the radius at that point P. So I need to work out the gradient of that radius. So just say that again. The gradient of the tangent is perpendicular to the gradient of the radius at point P. So my starting point is to work out the gradient of the radius at point P. So that is my y step of root 7 over 2 divided by my x step of 3 over 2. The 2's cancel, so that's root 7 over 3. So that's the gradient of the radius at point P. So the gradient of my tangent, given it's perpendicular, you flip that over, change the sign, so that's minus 3 over root 7. So I can now go and find the equation of the tangent at L, because I know the gradient minus root 3 over minus 3 over root 7, and I know a point on the tangent 3 over 2 root 7 over 2. So y minus y1 root 7 over 2 equals the gradient m minus 3 over root 7 multiplied by x minus x1, x1 being 3 over 2. So I've then just done the claw on the right hand side to give me this. I've then added root 7 over 2 to both sides to give me my equation of the tangent being y equals this. Now you could go and rationalise these two terms, so that's why I've put down or equivalent, but this is its non-rationalised format.